All right. If f of x is equal to f of x plus 1 over 7x minus 2, then f prime equals what? This is going to be a pretty simple quotient rule problem. I don't reckon you guys will probably even need to watch the video, but I'll do it anyway. Low d high minus high below, draw a line and square below. Now, maybe the part about this that'll be helpful is the fact that you're probably going to be asked to simplify it. They're probably not going to leave it like this. So I'll go ahead and distribute the 5 here. So that's 35x minus 10. And then here I'll distribute the 7. And then we need to distribute this negative here, which is going to cause the 3 to be negative and the 7 to be negative. And the 35s will cancel out. And we have a negative 10 and a negative 7 on the top to make negative 17. So you will need to simplify, because anytime you're doing a multiple choice test, they're not going to leave it in unsimplified form typically. So that might be the one thing to watch out for on that. For number 2, I'll just refer you back to example 1, pretty similar. For number 3, we're talking about trig derivatives there. So I'm just going to say take a look at your 1.7 notes if you forgot how to do your trig derivatives. But other than that, it's pretty simple. Number 4 is the product rule. So on number 4, you're going to have two things that are being multiplied together. And your job is to do the product rule, which looks like this. So keep that in mind for number 4. Now, I know I'm breezing through these ones, but that's just because these problems, I feel like we've done them so much. Just as a little reminder is all that's in order. But number 5, I feel, is worth talking about. So let's talk about number 5. So this is a double chain rule. I have my outermost function as a sine function. I've got my innermost function as an x squared. Everything else is what we'll call the middle function, because it's not the externalmost function, but it's not the internalmost function. It's the one in the middle. All right, so when you do a chain rule, you do the derivative of the outside times the derivative of the middle times the derivative of the inner function. Now, the outer function is the sine, and the derivative of sine is cosine. And when you do that, you don't change the inside at all. It stays exactly as it is. The derivative of ln is 1 over whatever the inside is. And then finally, the derivative of the innermost function there is simply 2x. And we could simplify this a little bit. This 2x is really 2x over 1, which means that we have an x in the numerator. And that can cancel out one of the x's off the bottom here. And then this 2 goes in the top. And this is also a numerator. So I've got a 2 and a cosine ln of x squared in the numerator. And in the bottom, I'm just left with a single x term. And so there's that. So it's a chain rule with some simplification. Go ahead and take a look at number 6. Chain rule again. Looks like we're going to have a lot of chain rule. I want to find f prime of 2. So the first thing I need to do is find the derivative. The derivative of the outside function, which is the 7th power, is going to be 7. And then take 1 off the power. Multiplied by the derivative of the inside function, which is going to be 4. And then they want us to find f prime of 2. So we're simply going to be plugging 2 in there. Now this is 8, take away 9, which is negative 1. Negative 1 raised to an even power becomes positive 1. And we end up with a final answer there of 28. So do your derivative and plug in your answer. Let's go ahead and take a look at number 7 here. This is a chain rule that has a quotient inside of it. So it's a chain rule and a quotient rule. My outer function here is the power function. My inner function is everything else. So The derivative of the outside function would be 3, and then parentheses, take 1 off the power. All of the inside will stay the same. Derivative of the inside is going to be low d high minus high d low. Draw a line and square below. Now the thing about this one that's going to be challenging is the fact that we do need to simplify this a little bit. So first of all, I'm going to apply this exponent to both the top and the bottom. Now in the top, if I square this, I'm going to end up with 9x squared. And on the bottom, if I square that, I'm going to have 2x minus 3 squared. And I still have this 3 in the front too. Let's go ahead and simplify the other half a little bit as well. Multiplying these together, we end up with 6x minus 9 minus 6x. All right, then we can go ahead and multiply this 3 and this 9 together, because that's like a 3 over 1. So we do top times top, bottom times bottom, and I end up with 27x squared over 2x minus 3 squared times, here the 6x's cancel, and I'm left with negative 6 over 2x minus 3 squared. And the final thing I can do is multiply these two fractions together. So top times top, 27 times 6. 120 plus 42 is going to be 162. It's negative 162 on the top, x squared. And on the bottom, we could just put these together to get 2x minus 3 now to the 4th power. And that's probably going to be good enough right there. All right? So we have to simplify it a little bit. That's what makes that one a bit of a challenge. For number 8, I'm just going to refer you back to see example 6 that I did earlier. For number 9, what can we conclude about the line that's tangent to this function at 1, 1? Well, let's go ahead and start by finding the tangent line here. Now, for a tangent line, you need an x value, you need a y value. Now, that doesn't tell me much of anything, but we also need a slope. And to find the slope, we need to find the derivative. So I basically need to find this derivative here. So let's go ahead and do that. It's an implicit function. So when you take the derivative of something with an x in it, you just take the derivative like normal. But when you take the derivative of something with a y in it, you're going to apply the you're going to give it a y prime. All right. So I'm going to think of this. I'm going to rewrite this a little bit just to make it a little bit easier to understand. I'm going to rewrite that as a plus a negative 3 instead of minus 3x. I'm going to think of this as my a and this is my b, and we have a product rule going on there. So a, b, prime, and prime. So the derivative of this is going to be negative 3. B is y. A is negative 3x. And the derivative of that is y prime. Now when you take the derivative of that, that's going to be 3y squared, y prime. And then finally, taking the derivative on the other side there, we end up with 0. All right, so this is a little creepy looking, so I'm going to go ahead and simplify it a little bit. Right now I've got 3 minus 3y minus 3xy prime plus 3y squared y prime equals 0. All right, let's go ahead and get the y prime by itself. You don't necessarily have to do this, but I'm going to. I'm going to minus this 3 on this side to the other side. And this side I'm going to add 3y on both sides. So those go away now. As a result, I now have negative 3xy prime plus 3y squared y prime. Why did I do that? Well, the goal is I want to get y prime by itself. And like I said, it's not entirely necessary for this problem to do that, But that's how we've done in the past, so I think we'll stick with that. But I want to get y prime by itself. So you get everything that has a y prime on one side of the equal sign, and anything that doesn't have a y prime on the other. So now, after we've got that, we're going to factor out the y prime. And then finally, to get the y prime by itself, we're going to go ahead and make some more writing space here for myself. Just a moment. To get that y prime by itself, we're going to just divide both sides by everything that's in parentheses there. So that gives me the following. So there's my derivative, right? So let's go back to the original question. The original question is, what can we conclude about the line that's tangent to this function at this point? Well, a tangent line has an x value, y value, and a slope. We were in the process of finding the slope. The first step is to find the derivative, which I've done. The next step is to plug the numbers in that they give you. So let's do that. Negative 3 plus the y value is 1. The x value is 1. And the y value is 1. Okay? So on the top you end up with 0, and on the bottom you end up with 0, and that's undefined. Okay? So that means that the tangent line either doesn't exist or it's a vertical tangent line. Okay, those are two ways that you could end up having an undefined slope at a point. If you ever have a vertical tangent line, like if I had a tangent line that was vertical, the slope is undefined. But there's other times whenever you can have an undefined tangent line. It doesn't have to be a vertical slope. It could also be a situation like, let's say you had a piecewise function like this. Well, you can't draw a tangent line when it's broken like that, right? So in that case, you would say, well, the tangent line just doesn't exist. So we can know one of two things about the tangent line. It either doesn't exist or it's vertical. Now, just so you guys know, something that's useful to be aware of here is that, let's just say, I don't know if this is what happens on your problem or not, but if it is, I just want to make sure you guys are ready for it. Let's just say after you find your y prime and you plug in your numbers, you end up with 0 over something else. But it's not 0 on the bottom this time, because the reason why mine didn't exist was because I had a 0 on the bottom. But if you have a 0 on the top, that doesn't mean it doesn't exist. That means that you have a horizontal tangent line. Okay? Because that's when you have a 0 slope. So a 0 on the top means that you have a horizontal tangent line. A 0 on the bottom means that you have a vertical tangent line, or it could mean no tangent line. Okay, it would mean one of those two things. But this is basically the big aha here, is that final conclusion. But you guys are going to need to take your derivative and plug in your point, and you'll see, is it this situation or is it this situation, and from there you can come to your conclusion. All right, let's go ahead and take a look at our last one here, number 10. We've got another implicit function to take a derivative of. So when we do this, just a moment. We start by doing the derivative with respect to x, and then we put the entire function in brackets. All right. Let's start off easy. I'm going to do the 3. Derivative of 3 is just 0, so it goes away. We really don't need to write it. Derivative of x is 1. Now we got to do this derivative here. That's going to be interesting. Well, first of all, it's a chain rule. We have our outer function, which is the e function, And when you take the derivative of an e function, it just stays exactly the same. But we also have our inside function here, the xy. Now that's going to be a product rule. So derivative of the outside multiplied by the derivative of the inside. Now the derivative of this is going to be a product rule. So it's going to be a, b, a, b. So the derivative, I'm going to call it xa and y is like my b. So if I do a prime b, ab prime, it would look like 1y xy prime. So we now have the following if I just simplify it. So after that, we want to find, the goal is I want to find dy dx. Now that's just another way of saying y prime, right? So I want to get this y prime by itself. How do I do that? Well, the first thing we could do is we could divide both sides by this e to the xy. So that'll leave me with y plus y prime, xy prime, is equal to 1 over exy. Next, I would just minus this y on both sides, like so. And then finally, I would divide everything by x. So divide here by x, divide here by x, and divide here by x. So just put x in the denominator everywhere. And we end up with this. Now, I don't know if they would want you to get a common denominator here or not. So this, this might be an acceptable answer, but they might also want us to get a common denominator. So I'll go a little bit further just to see how to do that, but I'm sure you guys already have some ideas about how to do that. Let me make some board space for myself. But basically, just do your derivative and get the y prime by itself, and if necessary, simplify. Here we go. So to get these to have a common denominator, what I would do is I would just multiply the top and bottom here by e to the xy. And that would be it. Basically, I'm done now, right? I have 1 minus x e to the xy over x e to the xy. So it could be like that, or it could be like this, but either way, just look at your multiple choice options that they give you and you'll find it. But let's go ahead and call it a day there. So hopefully that was helpful, and we'll see you guys later.